how does the Tau meta language help with building the software and translating meaning between languages, whether it's natural language or controlled language or machine language? And how does that also relate to software specifications? Because that's kind of the heart of what Tau network produces, right? That's the output. Or if you disagree, I'm curious to how you define the output of the Tau network.
I guess that the metaphor, the way I understand TML, is the assembler of the whole endeavor. So there is these high-level languages, like, well, this could be the control natural language or the Tau language itself, that then is executed over TML. So as such, you can do whatever you want. Of course, it's very low level. So the thing that you can do in TML have to be very specific. And again, it is guaranteed that whatever it does it correctly, but it's too fine-grained. Then Tau is a much more abstract language. It's much closer to the cognition of people using them. So there are the notion of concepts and relations and transitions and programs, so that you can actually express your concept and software in the Tau that then will be compiled into TML. That's my understanding, but probably Ohad has a better way to say it.
The Tau language is also very low level. The layer to convert from controlled natural language or natural language to the Tau language, that would be a different layer. But Tau language had to overcome theoretical difficulties of speaking about truth of sentences in the same language and having the temporal dimension to allow it to be a specification language. And it achieves this in a mathematical way. If you see the Tau language, it will make little sense to you because it is a mathematical thing. But you can build on top of it something that relates to real life.
Can you expand on that, like building something on top of the Tau language, the Tau meta language? How does that connect to the original purpose of Tau, which was that collaboration, the consensus, and the construction of software in a decentralized manner? Because this is the underlying technology that facilitates that, correct? That goal of distributed software development.
Yes, but there is one important point to understand here, which is the difference between code and specification. To give an example, suppose you are in a new city, you want to reach from point A to point B, and you don't know how to do that. So you ask someone, and they tell you, you go straight, turn to the right, second turn to the left, and so on. They don't tell you how many meters, but they tell you second turn, first turn, and so on. And you ask another one, and they give you completely different directions that hopefully lead to the same place. How can you compare and make sure that those two sets of instructions lead you to the same place? Well, you cannot. At the same way, it is impossible to say that whether two programs are equivalent, as we spoke before. And programs are indeed instructions where the computer has to turn at each moment. But the specification, the requirements level, are of different nature. Your requirement is to reach from point A to point B. And this is not written in the language of instructions. You will need eventually to get the instructions, but that's not what you really want. Software is still in the Stone Age in this sense. You need to code the instructions. Why can't you let your Google Maps calculate the instructions for you in the software analogy? Why can't you just write the what, let the computer figure out the how? Another limitation of traditional coding is that you cannot have global statements. For example, I want to reach somewhere and go to a supermarket in the middle. Or a more software example, never send private data over the network. Never send private data over the network is not something you can code. There is no command that says never do that. You need to go over your whole code, all places that you send data, and all places that you declare data as private, and make sure that all pipes are connected correctly. Why can't you say, just don't send private data over the network? And that's it. Let it figure it out automatically. Another point. If we take the two directions instructions of how to reach from point A to point B, you want to ask the question, maybe they are not the same, but where do they agree? Well, that's a meaningless question. But the same way, if you have two different programs and ask, where do those two programs agree? That's a meaningless question. But if you have two requirements and ask where those two requirements agree, that's meaningful. The way to see it, the mathematical way that we look at it, is each requirement is really the set of all programs that meet those requirements. For example, don't send private data over the network is mathematically the set of all programs that don't send private data over the network. And then you come up with another requirement, which will be another set. And the agreement would be any program that is in both sets. So we have to move from programs to sets of programs. To your question, how coordination takes place, everyone can say whatever they want to say about the software, like never send private data over the network. And we look for programs that meet everyone's requirements. If each user would come up with a whole program, and you ask where two programs agree, as we said, that's meaningless. You cannot have programming by consensus, programming by agreement, which is what we do. If you stick to code and programs, you must move to the requirements level.
So, tying it into layers and the procedures, how do we get from, if I express my requirements, don't send my data over the network as one example, and of course there's plenty of requirements. So a software requirement or specification is, you said, the what, not the how. I tell you what I want, the outcome that I want to achieve. So how do we get from me expressing that in English or any other, French, Italian, German, whatever, any language, how do we get from groups of people expressing that to finding that agreement? Because we've set up all these pillars of these problems. So Ohad and Professor Franconi, now that we've set the stage, let's watch the play. How do you take those natural language discussions the three of us have about our requirements? What are the layers of abstraction that need to happen that you have solved to then get from my natural language conversation, your natural language conversation, to get to those requirements and specifications? Can you walk us through that?
I can touch the first step, which is the natural language part, to logic. So this is something that is well known in people studying languages. So linguists and philosophers and psychologists, cognitive psychologists, in particular more formally, which is the aspect we are interested in, there are scientists that in the 60s and the 70s, from Montague to Chomsky, that completely clarified how and why natural language is related to a logical specification of it. So any sentence that we utter in a language, in English at this point, has a very precise meaning in some logic. And as we say, it's even too powerful because we can express paradoxes, something like, this sentence is false. Then I can express this, but I don't want to clearly transform this into logic because, as Ohad explained to us before, this will lead to an undecidable or a paradoxical logic, which would be meaningless for any usage. And indeed, such a sentence is also meaningless for us as a communication means. So we want to focus, as I mentioned before, to the very large fragment of meaningful sentences that when we communicate, we can understand each other. Now, how to translate this into a logical form? This is a well-known process. I guess we inspired ourselves to the Montague work, but it can be done with current technologies in a sort of non-positive way, has been called good old-fashioned AI. The GoFi thing, which people doing deep neural networks don't like because, well, this is useless, right? Well, I don't know, because understanding language is probably not useless. And the way people in deep neural networks understand language is they don't understand language. If you really want to do that, you have to go the other way, the way that philosophers and linguists and psychologists went through. So we can have a logical counterpart of natural language sentences. It's not easy in terms of capturing their own generality. That's why somehow, in terms of real-world application, this endeavor failed. The GoFi did not deliver robust natural language system as the deep learning community provides, because it's much harder, because we want to understand what the language says, as opposed to just statistically generate non-understood sentences. Okay, so we can have this logical counterpart. So indeed, by using logic, for example, we can replicate. This is what Aristotle did 2,000 years ago. He created the logic of syllogism that corresponds to the argumentation in certain particular patterns. And then once you have this language translated into logic, we can employ logic to check whether whatever we are saying is correct. If you counter-argue something against me, I can check, well, your counter-argument is false, so I can easily check. And that's somehow what our cognition does hiddenly. And that's a really interesting cognitive psychology problem. Why do we trust a good argumentation? And why logic? The logic is just a way to understand why this is true. It's very well understood why logic is the right way to make the argumentation, which has to do with the notion of entailment being grounded on model theory. So now we have logic, and Ohad can go on.
From a convenience natural language interface or controlled natural language, it will not be full natural language. You will not speak the way you speak with other people, but in a more limited way. From there, it should be translated to formal logic, which is a mathematical expression. And from there, all logical reasoning tasks like contradictions or consensus and so on will be done automatically by the very algorithms that we develop to show that a language is decidable, which is what we do. We come up with an algorithm that decides the language. It is a point to mention a major difficulty in this whole field, which is the necessity, the rare necessity to very much combine theory with engineering. Logic is a very deep theory, and it is also very computationally intensive. Naive implementation of logic is not going to work in real life. You need extremely good engineering as well as extremely good theory, and surprisingly or not, this combination is very rare in the software development world. And I guess this is one of our strength points, and indeed we invest a lot in both fronts.